Alright guys, so now let's take a look at the example at the section 4.3, rational equation, inequalities and application. This is very simple because what you need to understand is how to solve a rational equation and the inequalities and how to deal with the applications. So when you have a rational equation, let's take a look at the example number 1. When you have a rational equation, the first thing you need to do is multiply both sides by the LCD. So if you multiply both sides by the LCD, the idea is that you are going to get rid of your denominator. So the main idea is, how do I find the LCD? Well, we've seen that already many times, but mainly to find the LCD, you need to proceed the following. First, you need to write all the denominator. So for this, for instance, for this example, you got 5x minus 6, and 2, it's 2 divided by 1. So you got 1. I like to anyway write that because sometimes students tend to forget one of the denominator. They focus only on one, especially when the second denominator is just a number. In that case, the number is 1, so it's not a big deal if you forgot it, but if it was different than 1, it will be a big deal. So once you have written your denominator, you need to completely factorize into prime each denominator. Can you factorize 5x minus 6? No. So the answer is going to be 5x minus 6. Then it's going to be 1. And the LCD is the multiplication of each factor with the highest power, in this case 5x minus 6 times 1. So my LCD is 5x minus 6. When I multiply by 5x minus 6, I can see that my denominator of 5x minus 6 is going to divide out, and then I just need to distribute my 2, combine like terms, and find the value of x. Pretty simple, right? So when I have the example number 2 right here, it is exactly the same thing. Let's try to find the LCD. Well, the LCD, first of all, I need to write all the denominator. So it's going to be x squared. So it's going to be x. And I'm going to have 1. 1, why? Because it's 1 divided by 1. So my denominator 1 has to be there. Then, to find my LCD, I completely factorize into prime x squared, which is going to be x squared. X is going to be x, and 1 is going to be 1. To find the LCD, I need to multiply each factor with the highest power. So we have the factor 1, so 1 times what? Times the factor x, but I need to take the factor x with the highest power, which is going to be, in this case, x squared. So my LCD is going to be x squared. If I multiply by x squared, so let me zoom a little bit, and if I multiply by x squared on this side, and I multiply by x squared, so if I multiply by x squared right here, and I multiply by x squared on the other side, everything, I end up to have my denominator with divide out, and so I end up to have x squared plus 8x equal negative 7. Now I have a quadratic equation to solve, and I know how to solve a quadratic equation. If you feel uncomfortable to try to factorize right away your quadratic equation, don't forget that you can still find the value that makes your quadratic equation equal to 0 by using the quadratic formula. Okay? So I would like to remind you that you can still use the quadratic formula, negative b over 2a, plus or minus the square root of b squared minus 4 times ac divided by 2a. But be careful the way you are going to define the value of a, b, and c, because when you are using the quadratic formula to find the value of x, this is where you are going to make the main mistake. It is when you are going to define the value of a, b, and c. Okay? Now, for the example number 3, we have to solve a rational inequality. And when you want to solve a rational inequality, the first step is to try to pretend that you don't have an inequality, you just have an equation. And as any equation, as any rational equation, what you want to do is find the LCD and get rid of the denominator. Again, the LCD for this example is x plus 3. I think now you pretty much understand why. And then if you multiply by x plus 3 on the left side is going to divide out, and you end up to have x equal 2. Then we need to find the domain where the denominator is not equal to 0. So we have the domain and the denominator is not equal to 0. That means x has to be different than negative 3. Once you have these two values, the value will help you to solve your rational equation and the expression of your domain. What you want to do is pretty simple. You are going to try to graph a number line. On this number line, you are going to plug 0. Like this, you know that 2 will be on the right. Okay? And negative 3 is going to be on the left of your 0. That defined 3 interval. You are going to take in each of these intervals a value of x. For instance, you can take for the interval number 2 x equals 0. You could take x equals negative 4 for the interval number 1. And for the interval number 3, you could take x equals 3. And for each interval, you are going to substitute the value of x inside your rational equation, a rational inequality, and see if the number you choose in your interval check your rational inequality. So in the interval number 1, what do we have? Well, what I have is pretty simple. I got minus 4. So let me take another color. I'm going to take another color. And what do I have? Well, I have negative 4 minus 2 over negative 4 plus 3. That gives me a negative 6 divided by negative 1, which is 6. So my rational inequality is okay because it is supposed to be greater or equal to 0, greater to 0 or equal than 0 or equal to 0. If I do the same thing for the x equals 0, I'm going to have 0 minus 2 over 0 plus 3, which is negative 2/3. That is negative. And I'm supposed to find something greater than 0 or equal to 0. So that is not okay. That is not possible. That is not okay. All right? Now, the interval number 3, I'm take x equals 3. And when I have x equals 3, I end up to have 3 minus 2 divided by 3 plus 3, which is 1 over 9, and it is greater than 0. So at the end of the day, what I end up to have is the interval notation, minus infinity, negative 4. I will have a parenthesis next to the minus infinity, or actually it's not negative 4, it's negative 3. So let me rewrite that. It's negative 3. I don't know why I put negative 4, negative 3. Union, open parenthesis 2 plus infinity. Always a parenthesis next to plus infinity and next to negative infinity. And you have a parenthesis next to the 3 and the 2 because this value can be has to have a parenthesis as we defined it as value that your domain needs to be, as well as your, and if I just go back, it will be easier for me to tell you that value that find your when you try to solve your rational equation. Okay, now inverse variation. When we try to solve problem about inverse variation or joint variations, actually we could even talk about direct variations. It's all about the knowledge of how to translate a problem every time they are going to talk to you about a direct variation, inverse variation, or joint variation. Well, let me present you that on the side right here. And so what do we have? When we're having a direct variation, let's say y varies directly with x, y varies directly with x. Well, I'm going to translate that with y equal k times x. K is the constant of proportionality. K is the constant. And when I vary directly, y equal k times x. Of course, I'm dealing right now with y and x, but I can deal with any kind of variable in a direct variation or an inverse variation. And this is where I'm a little bit different than your note. I like to write when you have an inverse variation, then if you have y varies inversely with x, I'm going to translate that into a mathematical language, which is going to be y equal k times, there is always y equal k times what? The inverse of x, and the inverse of x is going to be 1 over x. Then if you want to write that as k divided by x, why not? But I think it's nice to have k times and then the translation of inversely with x, because sometimes we don't, student does not make the link between the inverse with x when it is k divided by x. They are able to see much better when you see 1 divided by x as the inverse of x. Now, the idea of the joint variation is very, very simple, because when you have a joint variations, you translate that with a multiplication in between the variable. So let's say you have y vary, actually I'm going to take the definition right here. Y vary directly with x and inversely with the square of t. Why not? That is a joint variation. And a joint variation, specifically with and, will be translated with a multiplication. So first of all, I'm going to have y equal k. K times what? K times x, because it's directly with x. So I'm going to have k times x, and multiplication for and, inversely with the square of t, and with the inverse of the square of your t. And that is a joint variation, ladies and gentlemen. Now, if you take a look at your example number 4, please pay attention, because the main problem that you have when you have to deal with a word problem is your inability to read properly your problem. Remember, it's not the first time we have to deal with a word problem. So when you have to deal with a word problem, 2 advice. First of all, take your time to read your problem. And second of all, try to represent your problem in a different way. All right? So let's read this problem first. The strength of a beam varies directly as width and thickness squared, and vary inversely as length. Right away, when you see and, you're thinking, oh man, it's going to be a direct variation, a joint variation. Then you will have to define the variable, and you will have to define the variable with letters, S for strength, W for width, T for thickness, and L for length. And then what you're going to happen is pretty simple. S vary directly with the width. All right? S equal K times W. And the thickness, and t, but the thickness squared, so it has to be squared. The and has been translated with a multiplication, and then they are telling you inversely with the length, so with the inverse of the length. Alright guys, so I'll let you read the rest of the example number 4, and I'll let you do the example number 1, 2, 3, 4, where you have all the steps that I already done with you, and the example number 5. I will do the example number 6 and the rest of the problem, 7, 8, and 9, in another video. Thank you very much.